question B, please take note that this is the continuation of the previous lesson that we had, where now we solved question A. So in this video, we will be solving question B. Before we continue, please don't forget to like, subscribe, and click the notification bell so that you get updated every time I post. So let us get going with question B. So in question B, they say determine the nth term as well as the 100th term for this sequence. So in the previous lesson, we got the next two terms of the number pattern, and we found that those two terms, it's 86 as well as 121. Okay. So now moving on to B, and I would like to erase here. So we know, let me just write it down. We know that T6 is 121. Okay. So now, okay, let me erase even here on the right, so that we can have space. Perfect. So now, for me to be able to get the nth term or the general term for this sequence, I need to get the second difference first. So I'm going to continue here and get the second difference. And remember, this is a quadratic sequence, so we are expecting it to have a common or a constant second difference. So let us see. So 17 minus 11, that is 6. 23 minus 17, that is 6. 29 minus 23, 6. And 35 minus 29, that is 6. Okay, and yes, indeed, we can see it has a second constant difference. So yes, indeed, it is a quadratic sequence. So now, to get the general term or the nth term, remember, I'm going to just draw a line here. Remember, the general term or the nth term equation is Tn equal to an squared plus bn plus c, where now a, b, and c are constants, right? So now we need to get a, we need to get b, we need to get c. So to get a, remember what we said? We said a is half of the second difference. So to get a, we will say 2a is equal to the second difference. And the second difference in this case is 6. Okay. So that's a second constant difference. So basically what you do, you say 2a and you equate your 2a to the second constant difference. And in this case, the second constant difference is 6. So then you divide by 2 both sides. Divide by 2, divide by 2. 2 and 2, they cancel. And then a is equal to 3. Then now to get b, you'll say 3a plus b, and you're going to equate this expression to the first term of the first difference. So you say 3a plus b, and you equate that 3a plus b to the first term of the first difference. And the first term of the first difference in this case is 11. Then you're going to have 3 into our a is 3 plus b equal to 11. And 3 times 3, that is 9, plus b equal to 11. Then this will be b is equal to 11 minus 9, that is 2. Okay. Then now, to get c, you'll say a plus b plus c equal to the first term of the pattern. And in this case, the first term of the pattern is this here, which is 6. So you're going to equate your a plus b plus c to 6. And then the first term is 3 plus b is 2 plus c equal to 6. And then 3 plus 2, that is 5, plus c equal to 6. So c is equal to 6 minus 5. So c is equal to 1. Okay. So now we have all the constants. We have a, we have b, and c. So we can just plug them here, substitute them into our equation. So our a is 3 plus, and then our b is 2. And then lastly, our c is 1. Okay. So we have our general term, or the nth term, which is, let me write it in red. So our nth term, or our general term, is 3n squared plus 2n plus 1. Okay. So now to get the 100th term, we're just gonna substitute 100 where there is n. So it will be 3 times 100 all squared plus 2 into 100 plus 1. And the answer here is 30,201. So we have answered B. We are done with B now. Now going to C, I'll have to erase here. Let me quickly erase. So now going into C. So for C, they want us to determine which term is equal to 162. Okay. So they want to know which term is equal to 162. So they basically want n here. So we have our nth term, or our general term, as Tn equal to 3n squared plus 2n plus 1. So now they want to know which term is equal to 162. So I'm going to equate my Tn to 162. So it's going to be 3n squared plus 2n plus 1, which is my Tn. And I'm going to equate that to 162. Then from here, I'll say 3n squared plus 2n. Then I'll transpose the 162 to the left. And this will be minus 161 equal to 0 on the right. Then from here, to solve for n, I suggest that maybe you use a quadratic formula, which is n is equal to minus b plus minus the root of b squared minus 4ac all over 2a. Okay. Then our n now will be equal to, so you're going to substitute your values into the formula. We know that our a is 3, our b is 2, and our c is minus 161. Okay, so you'll substitute all these constants into the quadratic formula, and you should get an answer of 7, as well as, or another answer is minus, okay, let me erase here on the side. Another answer that you will get is minus 23 all over 3. However, n can never be negative, right? So this is not applicable. Okay, so the correct answer is n is 7. Okay, so to conclude, we'll then say, therefore, term number 7 is the one that will be equal to 162. Okay, so that is it, guys, for this video. See you on my next videos. Thank you.